So hello students, again this is the video of based on equilibrium, right? But here it is ionization constant of water and its ionic product. Means we are coming to discuss pH. pH numericals are again very important. So now you know that when water molecule combines with the water molecule, it forms H3O positive plus OH negative, right? So one water molecule acts as acid, another acts as a base, because one molecule gains H plus. So that molecule which loses its H plus ion is called a base, and this is its conjugate acid. And for second molecule, as it easily lose H plus to form OH negative ion, so this is the acid and its conjugate base is OH negative. Now for this equation, equilibrium constant K equals to concentration of product upon concentration of reactant. Products are these, so concentration of H3O positive multiplied by OH negative divided by concentration of water. So now we know that concentration of water is always equals to 1, right? Because any term raised to the power 0 equals to 1, and concentration of water, as we know that water is a pure solvent, so its concentration term remains 0. So we can write this equation as water को हम इस side पर लेंगे, तो this is Kw. Now this is denoted by Kw, means this means equilibrium constant for water. It is equals to concentration of H3O positive into OH negative. Now this Kw is a new term which is called ionic product of water. So this Kw is the ionic product of water. Again remember that Kw is equals to hydronium ion concentration, which is equals to, for water it is 1 into 10 to the power minus 7, and OH negative's value is also, concentration of OH negative is also 1 into 10 to the power minus 7. So when we multiply these, then we get 1 into 10 to the power minus 14 m square. Now this is the value of Kw, right? Now again we know that if the concentration of H plus ion or H3O ions are more, that the solution is acidic. But if the concentration of H3O positive is lesser as compared to OH negative, then solution behaves as a base. And if both are equal, then we say that neither acidic nor basic, means simply we say that it is a neutral solution, right? Now from this equation, this is our equation, and from this equation, if we take a log on both sides, so we have minus log Kw equals to minus log hydronium ion concentration multiplied by minus log OH ion concentration. Now this minus log Kw is denoted by pKw, and this minus log hydronium ion is denoted by pH, and minus log OH negative is denoted by POH. So from this side we have this equation pKw equals to pH plus POH, and it is always equals to 14. As we know, for water pH is 7, POH is also 7, so 7 plus 7 equals to 14. Now what is this pH? So here you see that pH is the negative logarithm of hydronium ion concentration, or here we write pH equals to negative logarithm of hydrogen ion concentration. And if the value of pH is lesser than 7, means from 1 to 6.9, then we say that solution is acidic. But if it is greater than 7, like 7.1 to 14, then we say it is basic, solution is basic. But if pH remains 7, it means the solution is neutral, right? Now pKw equals to pH plus POH, or 7 plus 7 equals to 14, right? So this is all about your pH. What is pH? pH scale you know very well. What is pH scale? And then now coming to our next topic, Ostwald dilution law. It is basically used for ionization of weak acid. So here we take one example. Suppose this is the reaction CH3COH, which is a weak acid, combines with water to form H3O positive plus CH3COO negative. Right. Now for this, if we take initial concentration, now you know that in the initial state products are not formed, so concentration of products are equals to 0. बट जो भी हमारा कंसंट्रेशन होगा रिएक्टेंट का, सपोज कि हमने ले लिया, लेट द इनिशियल कंसंट्रेशन ऑफ द रिएक्टेंट इज C. नाउ आफ्टर टी टाइम if this concentration is ionized, so alpha is known as degree of ionization. सपोज कि C में से अल्फा जो है वो आयनाइज हो गया, ठीक है. अगर अल्फा आयनाइज हो गया देन वी गेट ओनली माइनस सी अल्फा, मीन्स जो बचा हमारे पास वो क्या बचा, माइनस सी अल्फा. राइट, किस में से माइनस सी अल्फा कर रहे हैं, सी में से. सो सी माइनस सी अल्फा. राइट, एंड हेयर कितना बन जाएगा, जितना यहाँ कम होगा उतना ही यहाँ पर बनेगा, बिकॉज हेयर यू सी दैट द रेशियो ऑफ दिस एंड दिस इज 1:1:1. तो जितना ये कम होगा उतना ही प्रोडक्ट बनेगा. रेशियो 1:1:1 है. अगर इन केस यहाँ पर 2H3O पॉजिटिव होता तो यहाँ पर रेशियो 2 हो जाता. तो उस केस में अगर ये सी अल्फा कम होता तो ये 2C अल्फा इंक्रीज करता. ये आपको ध्यान रखना है, ठीक है. तो यहाँ पर हमको क्या मिल गया कि ये कितना कम हो गया, ये सी अल्फा कम हुआ, ठीक है. इतना आयनाइज हो गया, जितना ये आयनाइज हुआ उतना ही ये बना और उतना ही ये बना. सो दिस इज आवर इक्वेशन. नाउ फॉर दिस इक्वेशन Ka equals to concentration of product, so CH3COO negative into H3O positive divided by concentration of CH3COOH. Water, again you know that water is a pure solvent, so we never take its concentration. So here we have this equation. Now placing the values, ये after t time, अगर हम इसको देखें तो ये आफ्टर टी टाइम, जबकि आयनाइज हो गया है, तो आफ्टर टी टाइम ये बचा कितना, ये बचा C माइनस सी अल्फा, ठीक है. और ये कितने बन गए हैं, C अल्फा. तो अब हम प्लेस करेंगे वैल्यू हियर. सो इट इज इक्वल्स टू C अल्फा इंटू C अल्फा, दोनों की वैल्यू रख दी, डिवाइडेड बाई CH3COH के लिए हो गया, C कॉमन ले लेते हैं इसमें से, C माइनस सी अल्फा से, सो C1 माइनस अल्फा, ठीक है. C से ये C कैंसिल हो जाएगा, सो वी हैव हियर C अल्फा स्क्वायर अपॉन 1 माइनस अल्फा. सो फॉर weak acids we have this Ka, equilibrium constant, equals to concentration multiplied by degree of ionization divided by 1 minus degree of ionization. If this value 1 minus alpha is very less, then we consider like we have this formula then only, that Ka equals to C alpha square, where C is the molarity, alpha is the degree of ionization. So this is called Ostwald dilution law, and it is from this we get a relation between Ka and degree of ionization.